So an important way that mass percent composition can be used in a real useful sense for chemists is to use when determining a substance's empirical formula. If you remember from previous chapter, an empirical formula is the simplest whole number ratio of atoms in a compound. It's not necessarily the actual number of atoms in a compound, but the simplest whole number ratio. And many times, if chemists have an unknown and they are trying to determine the identity of the unknown, they will first do experiments to try and find the empirical formula. And one way to find the empirical formula is to determine it from experimental measurements or data that include mass percent. So if you go on in chemistry and at Rose State and hopefully get to do labs in a real lab setting, you will do an experiment like this, where you determine mass percent composition and from that determine a substance's empirical formula. Now in Intro Chem, we're not going to do the experiment, but you are going to learn how to do the calculations associated with a problem like that. We're going to go through it step by step. So to determine the empirical formula for a substance. For example, an example problem that you would encounter in Intro Chem would be something like this. What is the empirical formula for a compound? And I give you the mass percents of the elements in the compound. So I have a compound and 45.55% is tin, 54.45% is chlorine. The first step in finding empirical formula from this data is to convert your mass percent to masses. And the easiest way to do this is to assume that you have a 100-gram sample. And that's something that you should do. Why should we assume? Why pick 100 grams as opposed to something else? Well, that's because when you assume a 100-gram sample, your mass percents automatically become grams. So essentially, if I assume a 100-gram sample, 45.55% of that's going to be tin, which is equal to 45.55 grams. So step one in finding the empirical formula, when given mass percents, just take off, first step, assume a 100-gram sample, take off the percent sign, and slap on a gram sign. So now we have actual amounts of our elements in the compound. So that's the first step. The second step is to convert those masses to our favorite unit, yes, the mole. And we can do that. We convert from grams of substance to moles of that substance using that element's molar mass from our friend the periodic table that you should have handy with you. So I see that tin has a molar mass of 118.71. Chlorine has a molar mass of 35.45. So I set that up. I set up my conversion so my gram units cancel. I'm left with moles. And so doing the appropriate division for both of those, I get this many moles of tin and this many moles of chlorine. So step two to finding our empirical formula is complete. We have converted those masses from step one to moles using the molar mass of the element. Next step is to find the whole number ratio of moles for each element. So if you remember, empirical formula is the simplest whole number ratio. I can't just have these numbers, these decimals, be subscripts. So to find the whole number ratio for each element, I look at the moles that I'm given, kind of put them here just to show you, and I divide each by the smallest number. So between 0.3837 and 1.536, the smallest number is 0.3837. So I divide both of my tin numbers, my tin number and my chlorine number by that, mole number by that. that will automatically give you a subscript of 1 for the tin. This answer is 4.003, which is pretty darn close to 4. So our final answer, our final empirical formula is SN. Again, remember you don't use the subscript 1 because it's implied. SnCl4. So that is our empirical formula for this problem. Now, there are going to be 2 occasions where you would not round a subscript number that's a decimal like this. We'll talk about that in 2 videos from now, okay? But this number is close enough to 4 that you can round it to 4. The 2 alternatives or the 2 exceptions we will talk about later. Okay? But you should know and be able to use these 3 steps for finding an empirical formula for a molecule given the mass percent of each element in that molecule.